Good evening everyone. I'm going to start today with exercise 1D, class 9 maths, exercise 1D. So before I start the exercise, I'm going to give you few informations here. We have already learned rational number. If you still remember, what is a rational number? A rational number is any of the form a by b is called rational number. Remember, a and b both should be what? Integers. Both are integers. A and b both are integers. And b cannot be equal to 0. We have already discussed why b is not equal to 0. This is the definition of a rational number. Rational number. Any number of the form a by b where a and b are integers and b is not equal to 0. So we have also seen that a rational number has what? Terminating decimal expansion means the division process will stop. Rational number, the division process will stop. It has a terminating decimal expansion. Remember, if it will not terminate or it has non-terminating, if it doesn't terminate, non-terminating, it will repeating decimal expansion. Means rational number, the division process either it will terminate or if it doesn't terminate, it will repeat. Like bar cases we have done, no? Last exercise we have done this type of bar. Means this is also rational number. Means 3 is repeating. It is not ending, it is not terminating, but it is repeating. And I already told you how to check also. If the denominator is of the form what? 2m into 5n, that means the division process will terminate. Otherwise, it will be non-terminating, repeating decimal expansion in case of rational number. Now, all these things you should keep in mind. Done? We have already discussed all these things, so I am not going to repeat again and again. I am just giving you a rough idea. Today we are going to do very important topic called irrational number. Irrational number. What is irrational number? See, what is irrational number? Irrational number means a number which is not of the form, a by b, where a and b are integers, and b not equal to 0. See, this is called what? Irrational number. Irrational number means what? A number which is not of the form. It cannot be of the form a by b. If it is of the form a by b, it becomes rational. So what is irrational? Which is not of the form a by b. So rational number we denote it by q. This is rational. Okay. Irrational number, you write q, on the top you write bar, not q. This is irrational number. This one is irrational number. Okay. Now you have all the types of numbers now. Rational number means like all those numbers, natural number, whole number, integers, okay, all comes under what? Rational number. And irrational number means what? Irrational number means the number which cannot be expressed in the form a by b. Example of irrational number will be root 2, okay, root 3, root 17, means which cannot come out of the root completely. Okay, that is called irrational number. So you have all the types of numbers now. Rational, irrational. Okay, this is few examples. So many examples you can give. Okay, Like if I say, till here you can post it and you can just note it down. Done? Okay. Now, what we'll do now? Till now, okay, when I say what is square root of 25? Square root of 25, it is rational or irrational? Tell me. Rational or irrational? See, root over 25, I know very clearly root over 25 means 5. It can come out of the root. The moment it comes out of the root, that becomes rational. Okay, done? This is rational. Now if I say, what is root 8? Root 8. Root 8, if I find out the factors, 8, 2, 4, 2, 2. Then I can write root 8 as 2 square into 2. Am I correct? 2 square and one more 2 is there. But 2 square has a pair, it will come out, 2 will come out, but 2 will remain inside. Now this, 2 root 2 and 2 are root 2 are multiplied. Means rational and irrational are multiplied. It doesn't become rational, irrational both. Whenever you have this type of multiplication where you have rational and irrational multiplication, it is still irrational number. Remember, if it is added, subtracted also fine. This is rational added with irrational. Still it is called irrational, not rational. It's not both also. Rational, irrational, don't say like that. Okay? Rational added with irrational, it is irrational. Now rational subtracted with irrational, root 5, it is still irrational. Rational divided by irrational, that is also still irrational. Remember, divided, multiplied, also same cases. Rational is 5, irrational is root 31. Okay, answer is still what? Irrational only. Remember, rational added or subtracted or multiplied or divided with irrational is always irrational. So this is few. So in your class 8 you have done no, find out the square root of 3, square root of 5, those comes under what? Irrational. Okay. Now we have got a big number now. Now here comes what? Real number. What is a real number? Real number is nothing but which has rational, and which has irrational. Rational and irrational together are termed as what? Real numbers. Okay? Now rational are what? Again inside rational you have what? Natural number, whole number, okay? Integers, I or Z, integers, or you can have A by B. All this comes under what? Rational. And what is irrational? Example will be root 2, which cannot come out of the root. Root 15 cannot come out of the root. This type of numbers are called irrational. So real numbers includes everything. What is a real number? Real number is nothing but collectively. Rational and irrational number collectively are known as what? Real numbers. Remember, this will be helpful when you are in class 10. Real number is nothing but the numbers, okay, together. With what together? Rational and irrational number together are termed as what? Real numbers. Remember. Okay. So let's see one thing. Let's see. Today I am going to teach you how to find out the square root. How to find out the square root. Then you will understand by yourself what is happening here. Suppose let's say what is the square root of, let's say square root of 31. Okay. What is 31? Is it rational or irrational? Yes, it is irrational. I am going to prove also later. I am going to prove how come it is irrational. I am going to prove it. Okay. Now let's find out the square root of this. Square root of this 31. If you still remember 31. and I'm going to find out what is square root of 31. I'm going to teach you. So remember, later on will be helpful for you. Now, okay, after that I'll write here point. I'll write so many zeros in pair, 0, 0, 0, 0 in pair. I will write down. So I make what? I write down here 6 zeros. That means 3 pair. 0, 0. From the ending you start pairing. 0, 0 pair, 0, 0 pair, 0, 0 pair, and 3, 1 pair. Okay. Suppose you have to find out square root of 2, then you will write down here 2, 0, 0, 0, 0, 0, 0, like this. As many zeros if you want, you can write so many zeros. There is no any boundary, because after point we can write as many zeros we like. But here what am I doing here? I am writing in pair, because square root means in pair. I have to write down. Now see here 0, 0 pair, 0, 0 pair, 0, 0 pair, but 2 doesn't have a pair, so 2 is alone. Okay, like this. So let's find out this one first. Now whatever, see very carefully, one way if you know, one question if you know how to find the square root, the remaining is very easy. Okay, same way only. Now whatever number I write here, here also I should write down the same number. If I write here 2, here also 2. 2 2s are 4. But I have to check this both. Okay, I have to check this both. 31 I have to check. So I will write here 6. If I write 6, here also 6. 6 6 are 36 is too big. So I will write here 5 5s are 25. It's not that you write a 5 6 are 30. Not like that. Whatever you write here, here also you have to write same. Then you subtract it. Now from here you can go 11 minus 5 is 6. Now from here is 0. Then you bring down. Okay, what I will do now? I have to double this 5. I have to double this 5 here. So I will do like this. I'll add 5. So I'll write in the circle like this, so that you will understand that 5 is doubled. Now 5 plus 5 is what? 10. 10. 5 plus 5 is 10. Now I have to leave one space here, because one more number I have to choose. But it will be 10. One more number will be there. Yes or no? Obviously 6 will be too less. So I will bring down this, not single 0. I will bring down this double 0. Okay? I am bringing down double 0. Double 0 where I am bringing? After the point. So I should put a point here. All clear? I repeat again. I wrote here, I am finding out square root of 31. So square root of 31, I know that it will come in point only. So I am ready with 0 0 0 0 0 0. Okay? So I am finding out, I am putting here 6 zeros, having means 6 0 means 3 pairs. 3 pairs of 0. And whatever I write here, here also should be same. So 1 1s are 1, 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 25, 6 6 are 36, 7 7s are 49, like that. But here I choose 5 5s are, because the nearest one. 5 5s are 25. I subtract after that, I got 6. Now I have to double. There is a rule you have to follow. 5 plus 5 is 10. Then I have to keep a space here. This underline where I put it is for the space. I will be using different color here, so that you can understand more clearly. So this is the space. Okay? Space means I am going to write one more number here. The same number I have to write here. Okay? Now when I have to write here, it will be 3 digits. It will be in terms of hundreds. Yes or no? It will be in terms of hundreds, and we had only 6. That's why this number is quite less. So what I do here, I bring down this double 0 from here. Okay? Now is double 0. Is it there? Double 0. Now what I will do now? Now it becomes 600. It becomes 600 now. Now double 0 where I bring this after point, so I insert here point. Remember, don't forget all these things. Now when I put, I have to choose a one number. See, 101 into 1, not into 101 again. Okay? Not into 101 again. This is wrong. So if I put here 1, here also 1. Here, this one I am choosing. 1, if I put here 1. But it's not like 1 1. It will be as a whole. 101 into 1 is what? 101. So if I put here 2, 102 into 2, it becomes 2 2s are 4, 2 0s are 0, 2 1s are 2. Like that I have to choose. Okay? So I will choose 105 into 5. Let me see, is it working or not? Because this is 6. Okay? 5 1s are 5, it will be near. Let's see. 5 5s are 25, 2 remains, 5 0s are 0, and 2, 5 ones are 5. If you put 6, it will be too big. If you 106 into 6, 6 6 are 36, 3 remains, 6 zeros are 0 plus 3, 6 ones are 6. It becomes 636, and here we have 600. So what is the best one? Best one is to write here 5. If I write here 5, here also 5. Remember all these things clear? So far understood? 525. Then underline again. Now I have to double what? Not the whole number. Then the ones digit, the first one. I have to double this. Means I add again 5. Okay? So I'll be keeping one space here so that I have to choose one more number. Now 5 plus 5 is 10. One remainder. Here goes 1. So this becomes 1 and 1. Okay? Then what I will do now? I have to choose one number here. Before that, let me subtract this one. 10 minus 5 is 5. 9 minus 2 is 7. Okay? 9 minus 2 is 7. Now I got 75. Here I have 4 digits. So 75 will be less. So I will bring down this double 0 again. Understanding so far? Very easy, no? Then I have to choose here one more number. 110. If I put here 7 into here also 7. But it'll be quite big, because 7 ones are 7 and 7 ones are 7 again. 77. But here I have 75. So best way is to choose 6 only. So if I put here 6, here also 6. So 6 are 36. 3 remains. 6 zeros are 0. 3. 6 ones are 6. 6 ones are 6. Then underline again. Then double what? Double the 6. Understanding now, no? You have to double the 6. Means you have to add 6. Don't write in the extreme corner, because this extreme corner is meant for choose one more number. So 6 plus 6 is 12. One remainder. So this becomes 1. This becomes 1. This becomes 1. Clear up to here? Then I am going to choose one more number here. 6 plus 6, 12, 1 remainder. This one is 0 plus 1 is 1. 1 comes here, 1 comes here. Then let me subtract again this one. 10 minus 6 is 4. 9 minus 3 is 6. And here, what happens here? This becomes 4, no? 4, yes, 4. So, from here it goes again. From here it goes. So, this becomes what? 14 minus 6. 14 minus 6 is nothing but 8. Okay, up to here everything is clear. Now what I will do now, I will bring down this double 0 again down. Okay, now if I put here, this is what? 5 digits, here also 5. 1, 1, 1, 2. If I put here 8, here also 8. So it may not work, because 8 ones are 8 and 8 ones are 8. 88. But here I am getting 86. So here definitely 7 will work. Here also 7 will work. So what will I do now? 7. Here also 7. Here also 7. 7 7 are 49. 4 remains. 7 2 are 14 plus 4 is 18. 1 remains. 7 1s are 7 plus 1, 8. 7 1s are 7. 7 1s are 7. So here it becomes 77, 88, 9. You subtract again. You keep on doing. See, 0 is enough. 0 no more. But I can write so many zeros, right? Isn't it? Now you double this 7. 7 plus 7, 14. Like that. So do you think that this division process will end? Tell me. It will never end. Okay? This division process will never end. And you keep on trying, you will see that repetition will not be there. One number can repeat, but after that, it's no guarantee. Understanding? One number 7 can come in between, or 5 can come in between. But it will never repeat again. A group of numbers will never repeat. Like in rational numbers, we see that, okay, after some time, whenever we see the repetition, the next group also will be the same repetition. But here, it will be never repeated. Okay, will not have the 6, 6, 6, 6, 3, 3, 3, will not have anymore. You keep on dividing until and unless, I mean, you keep on dividing here, you will never come to an end. And the repetition also will not be there. You cannot put bar also. So this is the case for what? For irrational number. Irrational number means it is a number when we divide, the division process will never end and it will never repeat. Is it clear? Understood? No? See, we have seen. So this is irrational number. So this is also one way of proving why it is irrational number. How come root 31 is irrational number? So how come it is irrational number? The proof is, this is also the proof of this one. Why it is irrational number is the proof. Because rational means what? The division process will either terminate, or if it doesn't terminate, it will repeat. Yes? Understanding? But irrational number means in this case you keep on dividing also, it will not terminate and it will not repeat. So that means it is irrational number, hence proved. Is it clear? So I will write down one very important point here. Very important point here. Irrational number has what? Non-terminating, non-repeating decimal expansion. If the writing is not clear, same time I am reading it out. Irrational number has what? Non-terminating, non-repeating decimal expansion. Is it clear up to here? Understood? No? I showed you with the proof. It will never end. You keep 0, 0 again, you keep 0, 0 again. It will not terminate for sure. Understanding? And it will not repeat also. But don't try. Alright? Otherwise it will take a lifelong to complete it. So irrational number has non-terminating, non-repeating decimal expansion. Up to here is clear? So this is one way of proving irrational number. Anything irrational number. Okay. Now I will go to exercise. Okay, one more thing. That is one way of proving root over 31, because what we have seen, the division process, it is what? Non-terminating. Non-terminating and non-repeating. We have seen this one. That's why it is what? Irrational number. Irrational number. That's no? Okay. Now I'll do one thing. I'll start with the exercise. Okay. Before it's too late. Exercise 1D. I'll start with this one. What is the question number 1? You can see that question number 1. You have to do up to slap 1 only. I have already given you the exercise in the WhatsApp group. You can check. So, define an irrational number. How does it differ from rational number? Okay, before I start, okay. So, anyone having doubt can always comment me in the comment box. Otherwise, there are some students who has my WhatsApp number. We are already in a group, so we discuss there. You can send me the WhatsApp number in the group, in the YouTube comment, and I will add you in the group. That also can be done. Okay, question number 1. Question number 1. What is question number 1? Define irrational number. So you know what is irrational number? I have already given you. What is irrational number? Irrational number is the number which is not of the form a by b, where a and b are integers and b not equal to 0. That's the definition. Second part, how does it differ from rational number? What is the difference? Okay, the difference is what? Rational number has terminating decimal expansion or non-terminating repeating decimal expansion. Whereas irrational number has what? Non-terminating and non-repeating decimal expansion. Is it clear? Then one you can write it down as difference. So I'll not do number 1 because everything I explained it. Now let me see question number 2. Question number 2. Question number 2 is what? Examine whether the following numbers are rational or irrational. Examine whether the following numbers are what? Rational or irrational. So we just have to write. We don't have to prove it. Okay? We don't have to prove it. We just have to examine it. So if it is a proof, then it's something different. We have to do in a different way. Like when we have to find out the square roots. Remember, until and unless you have to find out the square root and you have to write it, okay, this division process will never end. Okay? It is what? Non-terminating and non-repeating. Hence, it is irrational number. Okay? Now let me do number A, sub number 1. Examine whether what? Root 5 is rational or irrational. Okay? Very clear. Root 5 is what? Root 5, it cannot come out of the root. It is what? Irrational. So I will write Q on the top. I'll write bar. Means irrational. We just have to examine it. And sub number 2. Sub number 2 is what? Root over 9. Root over 9 is what? Root over 9 is 3 square. Root over 3 square means 3. So that becomes what? Rational. Okay, if it can come out of the root, it is rational. Sub number 3, it is what? Root over 45. Root over 45, okay, 45 is what? Let me find out the factors of 45. 45 is 3 15 times, okay, 3 5 times and 5 1 times. 45 I can write 3 square into 5 because 3 is double and 5 alone. This 3 will come out because it has a square and it's multiplied. Multiplication, if you have like this, it can come out 3 and remains what? 5. Okay? Then this is what? Irrational. Don't think that is rational. Okay? Irrational. I already told you, rational multiplied with irrational, it is irrational. Now, sub number 4. Sub number 4. Sub number 4 is what? 5 minus root 2 and 5 plus root 2. Let me check whether this is rational or irrational. Let me see. Have you finished up to here? So I am just writing a bar like this. You can write down properly. Bar not means irrational. Q means rational. So let me see. I'll write down here. Sub number 4. Sub number 4. 5 minus root 2 and then 5 plus root 2. I have to check whether it's rational. Things are not clear here. We have to find out the product and then decide that whether it is rational or irrational. Just check. 5 minus root 2, 5 plus root 2. Is it not of the form A minus B? Next bracket is A plus B. This is algebra. A minus B, A plus B. In class 9, in class 8 also you have that A minus B into A plus B. I can directly write A square minus B square. I can directly write A square minus B square. Is it clear? So this is equal to what? 5 square minus root 2 square. Check. A minus B, A plus B. A are same. You see 5 are same and root 2 same and you check one is plus and the other is what? Minus. So it is of the form A minus B, A plus B. If these are in product, the answer is direct A square minus B square. So is 5 square minus root 2 square. 5 square is 25 minus square and square root can be cancelled and it becomes 2. Okay, not 4. 25 minus 2 is nothing but 23. So 23 is rational or irrational? Yes, it is. It is what? rational. It is clearly rational. Nothing is there. Root is not there. So don't decide here. You solve it. Like root 9. The moment we see root, do we say it is irrational? No. Because root 9, what can I write? 3 square. Square and square root cancel. 3 is the answer. So we say rational, no? So root is there though, but we have to solve. No? Then ultimately, whatever comes, then we decide whether it is rational or irrational. Here also I find out the product first. Okay? And then we have come to the conclusion that it is what? Rational. Done? Okay. You can pause the video to note it down. I'll go to sub number 5. Sub number 5. Sub number 5 is root 3 plus root 2. No, yeah, root 3 plus root 2 whole square. Now root 3 plus root 2 whole square. See, it is a plus b. Square will not go inside. If there is a plus or minus in inside, see, a plus b whole square is never equal to what? Simply a square plus b square. No, it cannot be. Square cannot go inside. If it is product a into b square, then only is equal to a square into b square. A minus b whole square is never equal to a square minus b square. A by b whole square will be equal to a square by b. In multiplication and division case, no, square can go inside or any power can go inside. But whenever there is a plus or minus, directly square will, or the power cannot go inside. Remember. So what will I do now? Here square doesn't go inside directly, so I have to use a plus b whole square. A plus b whole square is a square plus 2ab plus b square. We'll do in chapter 2 in detail again, but now you know already this formula. In class 8 also there was a chapter, no? Algebraic expression. There you have done a plus b whole square. Identities. These are called identities. A plus b whole square, a minus b whole square is nothing but a square minus 2ab plus b square. You can note it down. And a minus b, and then a plus b is equal to a square minus b square. All these things you can note it down, because in this chapter also we are going to use again and again these things. So a plus b whole square is nothing but a square plus 2ab plus b square. So let me write down this one. A plus b whole square is root 3 square, a square plus 2ab. 2 is 2, a is root 3 and b is root 2. Plus b square. B square is root 2 square. A square plus 2ab plus b square. A plus b whole square. Now root 3 square, simple, is 3 plus 2.